All right, we are entering our last whole chapter for the semester, and it's chapter 7, rational numbers as decimals and percents. So we're going to be looking at decimals and percents. So section 7.1 is just an introduction to finite decimals. We're going to look at some notation, connections between fractions and decimals, and then we're going to really concentrate our efforts on terminating decimals. So those are going to be decimals that terminate. They don't keep repeating. Okay, so what is a decimal? The word decimal comes from the Latin decem, meaning 10. The decimal number system has as its base the number 10, which is good because we've been working in base 10. So we can represent a decimal number using place value as to help us know what power of 10 we're looking at. So 12, we've already seen this first expression for 12, right? 12 is 1 times 10 plus 2 times 1. The numbers that come after the decimal start as 1 over 10 to the first, and then the second place value is hundredths, 1 over 10 squared. The third place value is thousandths, 1 over 10 cubed, and so on. So here I have 6 over 10 to the first, plus 1 over 10 squared, plus 8 over 10 cubed, plus 4 over 10 to the fourth, plus 3 over 10 to the fifth. Okay, so this is how we would write it in expanded form. We would read this number as 12 and, so this is why we were reserving the word and for when we hit decimals, okay? 12 and 61,843 hundred thousandths. That hundred thousandths comes from the fact that we're at 10 to the fifth, okay? All right, so here's another way to look at that. So 1 was in the tens place, 2 is in the units place. We read the decimal as and now we move into with THS's at the end, right? So tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, and so on. All right, let's try going the other way. Let's write a number, let's see, 2 times 10 squared plus 3 times 10 to the first plus 4 times 1 plus, let's see, let me do 2 over 10 squared plus 7 over 10 cubed plus 8 over 10 to the fifth. Can you write it as a decimal? So pause the video and try it yourself first and then come back and see what I do. All right, so hopefully you've tried. These first 3 terms are just regular scientific notation that we've seen already this semester. So this is 2 hundredths, 3 tens, 4 ones, and now the issue here is we started with 10 squared, right? 2 over 10 squared. There's an understood 0 over 10 to the first here. And let's see, then we go 10 squared, 10 cubed, and now we're also missing 0 over 10 to the fourth. Now here you've got to be real careful about those zeros, right? Okay, so what is the number that comes after the decimal? I have 0, 2, 7, 0, 8. All right. So that's how we would write that as a decimal. All right, you can pull out your blocks to help illustrate decimals to your students. So now instead of treating the long as a 10, we're going to treat it as a unit. So the long is our 1. And then if I break it down into its pieces, those smaller blocks that built up that 1 count as my 1/10. So if I wanted to represent the number 5/4, I would get out 5 longs for the 5, so 5 ones, and then 4 tenths. Now if I put all those together, what do I have? I have 54 cubes. Those cubes are each 1/10, so that represents 54 tenths. So 54 tenths is equal to 5.4. If I wanted to represent a decimal with more digits, so say 2.235, I can now think of the block as my whole. So the block is my unit. And so I'm going to have 2 units here, so 2 blocks, and then 2/10ths. A tenth of that block is a flat, so that's where these flats are coming from. 3/100ths, a hundredth of the whole, the block, is going to be the longs, and then 5/1000ths. All right, so you can use the blocks to help your students visualize decimals. I'm going to let you pause the video here and try an example, and then we're going to work on converting between rational numbers and decimals.